Hey everyone, I am Diksha. I'm a PhD scholar at IIT Delhi in the mathematics department. I could not uh, make an introductory screen or slide, so that's why I'm introducing. So I'll be speaking about relations and functions today. We'll be learning that. As the name suggests, this chapter consists of two parts: relations and functions. So, why do firstly I would like to motivate you guys to as to why to study relation and functions. So firstly, you can see in our daily lives there are a lot of relations. It is very the word relation is the same as its English meaning. So like a relation between a student and a teacher, a father and a son, a brother and a sister. So we want to mathematically study relations, and mathematically speaking, some examples of relation can be between two numbers if one number is less than the other, greater than the other, or between, say, geometric object like a line, if one line is parallel to the other, or if it is intersecting. And one example can be uh, s- related to sets. So I hope you have studied already sets and then you have moved on to this chapter. So sets like if A is a subset of B, this is a relation between uh, two arbitrary sets, right? All right. So this was kind of a motivation to study relations and function. And function is nothing but a special type of relation. We'll go into the details later. So the aim of today's lecture would be to just make a base and not intimidate you guys with very complicated jargons. All right. So the first thing you need to know, the very very fundamental thing is, what do you mean by Cartesian product of two sets, right? So uh, like I think you have already studied graphs in your maybe ninth, 10th standard. So what do you do is you plot, say, this point which is 1 and this is 2. So this is 1 comma 2, right? So this plane x y, you used to write it as x comma y axis, and this represents a Cartesian product. So what you are basically doing is you are what does this plane x cross y has? What are the elements of this x cross y? So just taking, so x is nothing but the real line and y is also the real line, just placed perpendicular to each other, right? So what does x cross y contain? We are taking all the elements of x and all the elements of y and just writing it in an ordered pair, right? So like 1 2 is one of the element of x cross y. So this x cross y is what we call as the Cartesian product of x and y, where x is the real line and y is also the real line in our case. So this again, this was just to give you a motivation again that you have already seen such Cartesian products, just not under the name of Cartesian product, right? So we'll define Cartesian product. Okay, so definitions. Okay, so in maths, definitions are very, very important. You have to be very, very precise with the definitions, and not there should not be any ambiguity in the definition, right? So, what will be the definition? So, Cartesian product of two sets. So there has to be two sets involved. So given two non-empty sets, say P and Q. I've for now taken non-empty sets P and Q. The Cartesian product, like in the above example, P was the whole real line and Q was also the whole real line, right? So the Cartesian product P cross Q, which is, or you should rather write, denoted by P cross Q. We say it as P cross Q, not P times Q. It's just not the norm. It's just said as P cross Q is the set. So P cross Q is a set. So now set has to have some elements, right? So now we are defining what does P cross Q contain. So P cross Q is the set of all ordered pairs. So just from P and Q. That is, so mathematically, if we write P cross Q will be nothing but P cross Q will be nothing but the set which has ordered pairs P comma Q. We write ordered pair like P comma Q, like you used to do in your 11th, 12th standard, right? Sorry, 9th or 10th maybe. P cross Q where P belongs to P and Q belongs to Q. All right. So what we have done, you have taken into arbitrary set P and Q. We are saying that P cross Q is another set which has ordered pairs. So be very careful that ordered pair, right? That P cross Q might be different from Q cross P. Okay. So we're not saying that P cross Q is equal to Q cross P. No. Q comma P. No. So P cross Q is first element coming from the first set and second element coming from the second set, right? So for now, I stated the definition for two non-empty sets. However, if either P or Q is a null set, that is P equals to phi or Q equals to phi, this is the denotation of a null set, then of course, then P cross Q will also be an empty set, that is P cross Q is C. Okay. So I hope the definition is clear to you guys. So we can do some examples based on the same. So just a very easy example just to showcase that what actually is a Cartesian product. So example, suppose A is the set which contains two numbers 1 comma 2 and B is the set which contains 3 4 5. Then the question is what will be A cross B. So what will A cross B look like? So by the definition, we what we have to do is we have to just place all the ordered pairs from A and B to form A cross B. So the ordered pair will look like 1 comma 3, 1 coming from A and 3 coming from B, then 1 comma 4 and 1 comma 5. Similarly, 2 comma 3, 2 comma 4 and 2 comma 5. So this will be our Cartesian product of A cross B. These will be the elements in A cross B. Okay. So you can see that this set has 1 comma 3 element, but 3 comma 1 is not in this A cross B. So you cannot say that 1 comma 3 is equal to 3 comma 1 or something like that. No, you have to have keep in mind the ordering. We are talking about A cross B and not B cross A. Okay. Similarly, however, we can also talk about the set B cross A, which will look like 3 comma 1, 3 from B, 4 comma 1 and 5 comma 1, and then we have all the pairs with 2, 3 comma 2, 4 comma 2, and 5 comma 2. So you can clearly see that A comma B is not equal to A cross B is not equal to B cross A. Okay. All right. So I hope the definition is clear, the example is clear. Now, some remarks which you have to keep in mind. Okay. First, when do we call the say when are the two ordered pairs equal? Say A comma B and C comma D are two ordered pairs. And when do we say that these are equal? These are equal if and only if तभी if and only if means तभी और तभी इसके अलावा किसी भी सिचुएशन में नहीं. If and only if A equals to C and B equals to D, right? So the first element is equal to the first and the second is equal to the second, and there is an and not if A is equal to C or and B or D are equal. So you'll not say 1 3 and 1 4 are equal. No. So the uh, both of the positions have to be equal to one another. That is A is equal to C and B equals to D. So this was one. Then what are the number of elements in A cross B if you know the number of elements in A and B? It's very easy to see. So next mark is if there are P elements in the set P and Q elements in the set say Q, then the Cartesian product then P cross Q has, we are just taking every pair. So it is very easy to see mathematically that P cross Q will have PQ X. So the cardinality basically the number of elements in a set if they are finite is called the cardinality. So the cardinality of P cross Q will be P dot Q, where P is the cardinality of P and Q is the cardinality of Q, right? So mathematically, and the cardinality is denoted by N. So mathematically, what will be the case? Enough if we know if enough P equals to P and enough Q equals Q, then enough the set P cross Q will be NP into NQ, which is nothing but QG. Okay. Now, so far I have just talked about the set where they have finite elements, a finite number of elements. However, I started with an infinite set, right? So this real line goes up till infinity, y also goes up to infinity. So you can see that this x cross y has infinite number of elements. So this is what our next remark is, that if A and B, if and just keep it P and Q are non-empty sets and either P or Q is an infinite set, then P cross Q is also an infinite set, right? Of course, because if the P is there's some A1, A2 and Q is going from B1, B2 so on up to infinity, then when you start writing the numbers of P and Q, you can have infinite many elements paired with A1 and infinite many elements paired with A2, right? The P cross Q will be, of course, infinite. All right. So far, I've talked about Cartesian product of two sets. However, we can also talk about Cartesian product of more than two sets. Like in the 3D plane we used to see, right? So this is a Cartesian product of R, comma, cross R, comma, cross R, where this R represents real life, right? So this is what my next remark is, that X cross Y cross Z is an ordered triplet which can be written as X, Y, Z. X belongs to X, Y belongs to Y, and Z belongs to Z. So basically, we can generalize it to how many number of sets we want. Okay. Based on this, let me do a couple of questions. So, question one, yeah, these are just the basics. I don't want to indulge in any complicated things as of now, and just want to set the base. Okay. Maybe you guys might find it trivial, but these should be very, very clear in your head. So, question one, if x by 3 plus 1 and y minus 2 by 3 equals 5 by 3, comma 1 by 3, then find the values x and y. Okay, just kind of pause the video here and try to solve it yourself. Just use this first remark. When are the two ordered pairs equal? Two ordered pairs are equal when first element is equal to the first element and the second element is equal to the second. So what do we do? X by, so if these ordered pairs are equal, this means that x plus 3 by 1 is equal to 5 by 3 and y minus 2 by 3 is equal to 1 by 3. So x by 3 equals 5 by 3 minus 1, 2 by 3, x by 3. Then just basic calculus. So x is 2 and y is 3. All right. So this was the question on equality of two ordered pairs, right? Second, on counting the number, if the set A has three elements and the set B equals 3, comma 4, comma 5, then find the number of elements in the set A cross B. So what will be that? Again, it is based on our second remark. So we have NA, number of elements in A3, NB, number of elements in B3, then N of A cross B is, we know that NA cross NB, which is 3, comma 3 dot 3, which is 9. So the number of elements will be 9. Okay. All right. As an exercise, I would like you, just a simple exercise, just nothing crazy, that if G equals 7, comma, so not. So you see that the set, I'm writing it in curly brackets and the order pair in round brackets. So this, if G is the set 7, comma 8, and H is the set, then I've already done a similar example, then find G cross H and H cross G also, they won't be clean. You also see if G cross, okay, let's not dig into that for now. Okay. Then you have to find the Cartesian product H cross G and G cross. It's just simple exercise for the brain. Just try to do this. All right. Okay. Also, you can do one more, that if A equals minus 1 comma 1, then find A cross A. Just triplet, because I've already defined what X cross Y cross Z looks like. Here in the example, I've taken X equals Y equals Z. Just do it, okay? Not difficult again. Okay. So next example, one more example I can do, which will also revise your concepts of the set theory, intersection union, and all those I should not say relation, but all the permutation combination of what you need to do in the set theory. So let A equals the set 1, 2, 3, and B equals the set 3, comma 4, and C equals 4, comma 5, comma 6. Then find, what do we find? Okay, let's see. Find first, you find A cross B intersection C. So what is this set? That uh, you have to find the Cartesian product. This is another set. What, how you can visualize it? That this B intersection C is another set, say D. So we have to basically find A cross D, where D is another set, B intersection C. Try to do this. Should not be difficult. So B intersection C is, what are the elements which are contained both in B and C, which is only 4. So A cross the set 4, which will be nothing but the set 1, comma 4. I'm taking element from 1, pairing it with 4, 2, comma 4, and 3, comma 4. Right? One more you can do. A cross B union A cross C. Okay? So A cross B is 1, comma 3, 2, comma 3, and 3, comma 3. Then you have 1, comma 4, 2, comma 4, and 3, comma 4. Similarly, A cross C will be there will be 9 elements. You can just calculate 1, comma 4, 1, comma 5, and 1, comma 6. Then 2, comma 4, 2, comma 5, 2, comma 6, and 3, comma 4, 3, comma 5, and 3, comma 6. So this is array cross. So A cross B union A cross C, just write the elements, all the elements, and with no repetition. That's what union is. That either it's in A cross B, or either it's in A cross C. So the elements will be 1, comma 3. I should use a different color pen. 1, comma 3, 1 comma 4, 1 comma 5, 1 comma 6, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6, 3 3, 3 4, 3 5, and 3 6. I hope I'm not missing anything. Just verify this. It should not be difficult again. Okay. And as an exercise, what you can do is you can, I've already computed everything. You just see what is A cross B union C and A cross B intersection B cross C. Okay. Just try to see this. All right. So this was, I think this should be enough to set the basics of uh, what a Cartesian product between two sets, and uh, even if not two, we can extend it naturally to more than two sets, right? So I hope this much should be enough, and you should be clear with what a Cartesian product now is. All right. So let's now uh, move to the next part of our not the next part, basically the first part of our uh, chapter, which is relation. So, so a relation uh, in the Cartesian product, what we did, we had two sets. We just blindly wrote all the pairs uh, which will be in the Cartesian product, every pair. But as the name suggests, in the relation, what we do is we will try to form a subset of the Cartesian product such that it has such that the elements in that uh, subset has a relation between them, right? So it will be clear as we go along. So firstly, the definition, or say maybe I can just start with an example that if A sum set 1 2 3 and B sum set 4 5 6. So if I want to see that all those the relation is all those x comma y such that x, okay, let me just say 2 comma 4, okay, such that x is less than y. This is such that, मतलब वो सारे pairs from A cross B, subset of A cross B, such that the first element is less than the second element. So what? So you see, firstly A cross B क्या होगा? A cross B होगा 1 comma 2, 1 comma 4, then 2 comma 2, 2 comma 4, 3 comma 2, and 3 comma 4. Right? So you can see 1 is less than 2, 1 is less than 4. We have strict inequality. This will not be in the relation. 2 is less than 4. 3 is not less than 2. This will again, and 3 is less than 4. So our relation will only have 1 2, 1 4, 2 4, and 3. So we have uh, taken out a subset from A cross B such that the first element is somehow related to the second element uh, uh, of the ordered pair that are in the subset. So this is a relation. So a proper definition, if you want to write, and this relation is usually denoted by by R. So the definition would be a relation R from a non-empty, of course, set A to a non-empty set B is a subset Please note that it is a subset of the Cartesian product of A and B of the Cartesian product A cross B. And the subset is derived by describing a relation. So, okay, the subset is derived by describing a relationship, right, between the first element, between the first element and the second element of the ordered pairs A cross B. Okay, all right. And so similarly, if A and B are equal, we can derive a relation from A cross B, A cross A. So, for example, let A equals 1, 2, 3, 4, 5, 6. Then we define a relation. Define a relation R from A to A by R क्या है? वो सारे XY. And how do we write it? वो सारे XY such that this is such that Y equals X plus 1. That Y is 1 more than the first element. Okay? So just try to see what all will be the elements. We don't have to write down what A cross A is first, because so it has 6 elements. A cross A will have 36 elements. So it's just not feasible to write all the elements. Okay, so just try to see. So what R will be? You just take. How do we need our second element? We want, if one is the first element, this second element should be one more than that. So 1, 2, then 2, 3, then 3, 4, then 4, 5, 5, 6, right? And now don't take 6 and 7, because 7 is not in A. Please don't commit this mistake. All right, so this will be the relation. So again, you have, I think we have already studied the set builder form or the roster method. So that's how we represent relation, right? Okay. And now very, very important, 3 words which are just very important throughout mathematics and not just this particular chapter: domain, codomain, and range. Okay. So if, sorry, if R is a relation from set A to a set B, then A, the set of the first element of the ordered pair, then A is called domain of the relation R, and B is called the codomain. And the set of all second elements in a relation in this relation in the relation R will be called is called range of the relation R, right? So what this is saying is if R is a relation, it has some elements, say x1, x2, x. Okay, I'll just. If R is a relation, these are elements x1, x2, x3, and x4, and this is some y1, y2, y3, y4, y5, and say y4. So suppose in Cartesian, this is the set A, this is the set B. In Cartesian product, every element we have all the order pairs. But if only in the relation it is a subset, and suppose just I'm taking an arbitrary relation that only these are related. That R has only, what does R has? R has only x1, y2, x2, y5, and x4. Let this let this be y4, x4, and y4. Then this A is called domain because the relation कहाँ से कहाँ है? A से B. अगर B से होता है तो B को domain बोलते हैं. The first set is the domain. The second set is the codomain. पूरा का पूरा जो है that is the codomain. And range क्या है? Very important. Second element, all the set of the second elements in the ordered pair in the relation R. मतलब सिर्फ वही second element जो किसी ना किसी डोमेन के एलिमेंट से रिलेटेड है. तो मतलब and range is, and of course the range is the subset of the second set, right? So range is, ये range second element क्या है? y2, y5, y4. तो range क्या है? y2, y5, and y4. Another method or another mathematical method to say what a range is, that if some element is in the range, then there exists some element from the first set such that the ordered pair is in the relation. Okay. Sorry. All right. And obviously, clearly, range is a subset of B is equal to the code. The range is the subset of the codomain of the relation. Okay, so coming back to our first example, or not the first, this example. So, what is the domain? A, codomain. रिलेशन कहाँ से कहाँ था? ए से ए, डोमेन ए, कोडोमेन ए. बट रेंज क्या है? रिलेशन ये था तो रेंज क्या है? सेकंड एलिमेंट. इनफैक्ट ये पूरा का पूरा ए आ रहा है इन दिस केस. नो, नॉट फुल ए. 2, 1 is not there. So range is 2, 3, 4, 5, 6. So this is the range. Okay. All right. So this was, so what we have done till now, Cartesian product. Then we moved to relation, and then we studied domain, codomain, and trace. So Cartesian product, just all the ordered pairs. Relation, a subset of the Cartesian product, in which elements are related somehow. And domain, first element of the relation. Codomain, second element. First set of the relation. Codomain, second set of the relation. And range, all the second elements in the relation. Just a summary of what we have done. Okay. Then just a note. Okay. So you see that a relation is a subset of the Cartesian product. Now, if the Cartesian product has finite number of elements, then we can explicitly say that how many number of relations can be possible between A to B, right? And that is nothing but the power set of the uh, Cartesian product, right? And we know what is the cardinality of the power set, right? You have already, I think, studied this thing in set theory. Okay, so the note is the total number of relations that can be found or not, or that can be defined from a set A to a set B is the number of possible, जितने नंबर ऑफ सबसेट्स होंगे ए क्रॉस बी के उतने ही नंबर ऑफ रिलेशन हो सकते हैं बिकॉज एनी रिलेशन इज अ सबसेट ऑफ ए क्रॉस बी वी कैन नॉट एक्सीड दैट सो इज द नंबर ऑफ possible subsets of A cross B, right? So what this note or remark is saying that कितने number of relations हो सकते हैं given a set A and B. It has to be a subset of A cross B. So जितने number of subsets हो सकते हैं A cross B के उतने ही number of relations हो सकते हैं A और B. And if it is finite, the cardinality of A and B is finite, so N is P and NB is Q, then we know that N of A cross B is PQ. And if a set has say P element or say suppose X elements, then it subset the number of the power set of this set has 2 raised to power X elements, right? I think you have already studied this. This comes from basically I don't know, from permutation combination formula. So I don't think maybe we'll go into the detail if we study that chapter. But right, so then and the total number of relations. So relations किसके सबसेट है A क्रॉस B के जिसमें कितना एलिमेंट्स है PQ. So the total number of relations possible are 2 raised to power PQ, right? So this was one thing. Okay, let us do some questions and we'll start with the chapter functions in the maybe the next class. So let's try to do some questions based on them, based on whatever we have studied. Okay. So first question is, let A equals 1, 2, 3, so on up to number 14. Define a relation R run A to A by कैसा है R कैसा है x comma y such that 3x minus y is 0, where of course where x comma y belongs to A. So the question is, write down the domain, codomain, and range of R. So, so you see that don't try to write what A cross A is. A cross A will have 14 cross 14 elements. It's just not feasible again. Okay, so you see I cross R में कैसे elements है, so that x y कैसे related है, 3x equals to, or say 3x minus y equals 0. That is y equals 3x. मतलब second element is 3 times the first. So just take first element vary करो. x को अगर 1 लिया तो y क्या होना चाहिए 3. x को अगर 2 लिया तो y क्या होना चाहिए 2 into 3 6. And also keep in mind that the second element is also in x and y both are in A. तो जब तक A में आ रहा है तब तक लिखते रहो. तो x को 3 लिया 9, x को 4 लिया 12, अब x को 5 लेंगे 15, it will go out of the set A. So सिर्फ इतने एलिमेंट्स आ सकते हैं, राइट? तो हमारी डोमेन क्या है? डोमेन इज the first set, which is A itself. Codomain is the second set, which is again A itself. And range is the second element of the ordered pairs in the relation. So the range is 3, 6, 9, and 12. Okay. So this was on a finite set as of now. I have just given examples of relations on finite set. Let's try to see an example from an infinite set. Or maybe we can do one more example on power set first. Okay, so if A is B is 3 comma 4, find the number of relations from A to B, right? So what we have, A की cardinality 2, B की cardinality 2. So and A cross B की cardinality will be 2 cross 2, which is 4. So the number of possible relations, two to the power 4, right? So these are the, which is 60. Okay. Okay. As an exercise, just again on a finite set I'm giving. As an exercise, what you can do is take A to be 1, 1, 2, 3, and 5, B to be 4, 6, 9. Then define a relation R from A to B by R कैसा है? वो सारे एक्स वाई लेने हैं हमें R में, such that the difference between x and y is odd and X belongs to A and Y belongs to B. Okay. Determine domain, codomain, and range of functions. All right. So I had one question. I think again, one more easy exercise can be let A equals X comma Y comma Z B equals 1 comma 2, then find the number of relations from B to A. Okay, please note I have written B to A, though I don't think it will make a difference. Just be careful. Okay, okay, maybe. So this was all for uh, the relation, Cartesian product and relation. This is all we need to know to get to the most important part and final part of the chapter, which is function. So functions again. So what we started with was Cartesian product, then relation, and then we want to move to function. So the Cartesian products, subordered pairs between two sets, where relation a subset of that, and further function is again a special type of a relation. Okay. So let me just give an prayer. Maybe we can just do the definition in this class, and later in the next we'll go into the details. Functions. The function. So हमारे पास पिक्चर कैसे वेन डायग्राम कार्टेशियन प्रोडक्ट इसके अंदर फिर रिलेशन फिर फंक्शन राइट तो सबसे बड़ा है कार्टेशियन प्रोडक्ट then relation is special type of not a special but a subset of that, and then we have function which is a special type of a relation. So functions or say function is a special type of a relation. All right. Okay. So definition, and what is the speciality? That a relation f from a set A to a set B is said to be a function if every element of set A has only. Okay, I'm really sorry. I think I forgot to mention what is an image. So I will. This is also very important that image. The second element is called all the pairs in R, the second element is called the image of the first element. Okay. So 3 is image of 1, 2, 6 is image of 2. So you see that this is what some sort of a mapping that ये element यहाँ map हो रहा है. So this is the image of this element, right? 9 is the image of 3, 12 is the image of 6. So what does function say? That if every element of set A has one and only one image in set B. मतलब कि अगर ये सब एलिमेंट्स हैं ए और बी के, तो एक एलिमेंट सिर्फ एक ही पे जा सकता है. ऐसा नहीं हो सकता कि एक एलिमेंट दिस इज नॉट अ फंक्शन, राइट? कि एक एलिमेंट की सिर्फ और सिर्फ एक ही इमेज होनी चाहिए इन द सेट बी. So how do I remember it? As that this is not a function. So how do I remember that one bullet cannot go to two different places, right? But this this is very much possible that two elements can have the same image, right? So what is not possible is, please try to understand this, that one element cannot have two images, then it is not a function. But two elements can go to the same image. That is a possibility. Mhm. That it is not denying the definition of function. Okay. So how do I remember? I'll recall that one bullet cannot go to 2 points, but bullets can go to 1 point. Just this is just how you can remember the definition of function. Okay. So what? How do we say it? The notion. If f is a function from A to B and AB belongs to F, then we say f of A is equal to B, where B is called the. तो हम क्या कह रहे हैं? F पे F मैंने A पे लगाया तो मेरे पास क्या आएगा? B. मैंने कुछ F लगाया किसी एलिमेंट पे तो मेरे को दूसरा एलिमेंट मिल गया B. तो B is called image of A and A is called, okay, just be precise. B is called the image of A under F and A is called the free image of B under F. ठीक है? तो F मैंने A पे मैंने F लगाया, मुझे B मिला. B को क्या बोलेंगे? इमेज. और A को क्या बोलेंगे? फ्री इमेज. ठीक है? और किसके अंडर? अंडर द फंक्शन F. And one more denotion, that F from A to B is denoted as F colon A going to B. Okay. So we'll go into more detail on function in the next class. So but just again, so I'll leave so many exercises in between class. Try to solve them. It will help you clarify your topic. So let n be the set of natural numbers and the relation R be defined on n such that R equals x comma y, where y equals to 2x, x comma y belongs to x. The question is determine domain, codomain, range of R. And the second question is this relation a function? So for that, what do you have to determine? That each element has only and only one image. Okay? So try to do this. It will be helpful for you to understand the topic more, and we'll go into the details in the next class. So thank you. I'll stop here and we'll meet in the next class. Okay. Thank you.